Today's lesson is the cumulative distribution function. Before we start, I just want to revise a little bit about what we've done, especially the PDF. As you can see, the histogram on the left is like each column is actually representing the probability. So if you add it all up, the sum of all the probability must be 1. Now that's sort of like a discrete, okay? Each bar, each column is like indicating one single value, like 2, 6, 10, 14, 18, 22, something like that. On the right-hand side with the curve, what happened was if it's a continuous data, that 2 is not just 2 anymore. It's like all the way up to 2, like 6, all the way up to 6. So all that little numbers in between are included now. Rectangles, the little bars gonna be like there'll be thousands, millions, infinity numbers of them because as you know, we have to count like 0.002, 0.02, 0.1. All those actually. Okay, so all that little values in that discrete column, it's going to be divided into small little pieces of rectangles. So therefore, this is what it means by the number of columns with a 0 width, because everything's going to be so thin, it's almost like 0. So that's what it means. And therefore, it's very, very hard to represent it as a column or the bars or rectangles. So that's why the curve starting to form. Okay, and of course, just because you got lots of little rectangles doesn't mean the whole total will change, wouldn't it? Total will be still same, 1. Now, what we're going to do is a cumulative distribution function. Okay, with the PDF, the probability density function, and we were trying to find the P of probability, big X is less than equal to little x. That's what I'm going to call it. Now, what does that mean? It means that the big X here, big X is all the possible values you're going to get. And then little x is the specific value that it's going to go, like new final limit, the biggest limit that you're going to get. Okay, so our domain is A and B still, but we're going to give a value x so that we can find the area under the curve up to that limit. Okay, so before with the PDF, we had to integrate every time we got like a new set of limits. But with a cumulative distribution function, we also call it CDF, it gives us a general formula. Okay, so what does that mean? It means, I've just summarized it underneath here. So what it says is the CDF is a general formula, which is integration because we're talking about under the curve area, for finding an area under the curve with a general limit, which is a to the x. A is a starting point, okay, which is our domain A to B. And also, it actually contains the meaning of probability of big X is less than equal to X. Okay, like I showed you the diagram above there of the PDF within the domain A and B. So we don't need to integrate each time when we have a different set of new limit within the domain. Okay, so let's have a look at what all that means. It sums up on the next part here. So I said CDF is a general formula. So what does that mean? It's just a capital F of X equals. Now this new limit here, that A is a starting point. Okay, starting point. Now you might say, Miss, why can't we just go A to B? Well, if you do A to B, we know the answer. It's going to be 1. So it's no fun, okay? Now, what we want to know is in between that A and B, we're going to create a set of partial limits, if you like. So total limit domain is A and B still, and that under the curve of the A and B is 1. That's not going to change anything. But what we want now is part of that. Okay, so partial limit. Now, because it's a general formula, that x, finishing point, x here, we don't know. We don't know because it's going to depend on each question, isn't it? It could go to A to 4, A to 6, whatever it is. So we're going to make it x as a general term of the finishing point, okay? And then if we can get the formula for the general, we can use that formula to find its different parts of partial limits. So now we got is A to X. That's what we call it, a general formula. Okay, so the X can change, depends on the question. Okay, depend on the area. Okay, so let's have a look at the example. So a continuous probability function is given by f of x equals 4x cubed all over 255. Now that's actually, PDF, right? And defined in the domain 1 to 4. Okay, so 1 to 4 is our set limits. Find the cumulative distribution function. That's what it means, is just find the formula, find the general formula. That's what it means, okay? Part B, using that general formula, we need to find all this probability with partial limits. So how are we going to find the general formula? F of x equals, now remember, it always starts, for the starting point doesn't change. It's the finishing one where it goes up to, it's always going to change. So 1 to x, 4x cubed dx. And of course, I'm going to put the constant out. And x cubed dx. Then if I take the quarter out, it'll give me, so my general formula for this continuous probability function, it's going to be f of x equals x power 4 minus 1, 255. That's what it is. Using this formula, we are going to answer all the questions from here on. Now, remember, this CDF is only satisfies, always has to be less than the limits one. So we are looking at, that's like starting 1 here, 1. And it was 4, wasn't it? 1 to 4, that was domain. And x, we don't know, could be here or could be somewhere else. Okay, so all these part, just before the x is a capital X, big X. And of course, whatever that we want to find, whatever that it's here, it has to be less than or equal to little x. Okay, that's what it means. Now, that's a CDF. CDF gives it this much. From the starting to where it wants to be. Okay, always from the start, which is, in this case, it's 1. Okay, so we don't have to integrate anymore. That's the good thing about CDF. It's a general form formula. So I'm gonna have, it's gonna go to up to 3, isn't it? That's our little x, by the way. So here it's the 3 here. Okay, so I'm going to put 3 here. And then, of course, 3 to the power of 4 minus 1, 255. Put all that in your calculator. You will get that. Leave it as a fraction because it's more accurate. The answer, I want you to write it as what it's given. We want to find the probability that all the possible values that less or equal to 3, the probability is 16 over 51. That's it. The next one. Now, doesn't really matter if it was like less than or less than equal to, So I will tell you some more before, but it's going to be the same as if I did this. Why? Because same is 0, isn't it? Remember, one single discrete value, there's no area, so it's going to be 0. So this part, isn't that what it is? Right? That's just together, and that's just 0. So it has to be same. F 1.6. I'm going to substitute in 1.6 to the power of 4. Oops. Minus 1, 255. And you put that in your calculator, you'll get 0.0218. Therefore, probability of big X is less than 1.6 is 0.0218. Okay, so let's have a look at this. Now, it says here, we can use the cumulative distribution function, CDF, to find the probability such as here and here. Now, this is just in between the domain A and B. Okay, so that's all right. But this, what does that mean here? Remember, CDF gives us X is less than equal to, okay, the whatever the A, from A to there, okay, so little x. But if it was like the other part, what do we have to do? That's what it means. So find the cumulative distribution function. So basically they're asking you to find a general formula. F of x, because it's a general, I'm going to go the beginning starting point to the x, because we don't know. And then 3x squared over 335 dx. Okay, that's what it is. And of course, I'm going to take the constant out. X. This is just straightforward. So I'm taking the 1/3 out. So this one we want over 335 minus 8. Therefore, my f of x equals x cubed minus 8 over 335. Okay. Next one is the let's have a look. So this is something different here. What is asking us is like this is where this is. Okay. So all the possible values are bigger than 4 or equal to. With the CDF, only gives us from the start to where it's supposed to be. That's up to 7 here, 2 here, and the 4s here. CDF gives this. This is what we're giving. Okay. So CDF only gives it this much. And we have to find the other side. That's what we want. Okay. So what do? We're going to use, do you remember complementary probability? We're going to use complementary probability. So if we could do one takeaway, that's what I'm going to do. So we know how to get this one with CDF, right? And then just take away from 1 because we know the whole under the curve is 1. I'm going to have to find this first. X cubed, I'm just going to write it here. F of x is just the general formula. So x to the power of 3. Okay, so I'm going to put 4 cubed minus 8, 3, 3, 5. Now, when I do that, I will get 56 over 335 here. Okay, now I can do my probability that it's going to be big X is bigger or equal to 4 equals 1 take away. That is the other side. That will give me 279 over 335. Okay, so that's what we're going to get. Okay, so remember, CDF, it just gives you from the start. Remember that when we did the formula, we did the start to where it's supposed to be. Okay, that's our starting point, wasn't it? From the domain. Only represents the first parts of the area. Okay, so next one. Now this time what we want is this, the middle, not just the beginning part of it or the end part of it. It's what if it was in the middle section, the area we want. That means we have to think about getting the area where from the start to the up to I've got here is if I can find area from here to here first and then take away the area from here to here, we will get the middle part. That's what it means here. Okay, so let's do that. Now again, we don't need to do the integration at all. What we got was the general formula that goes from start to x. That was x cubed minus 8. What was it? 335. So we got this formula, okay? So I'm going to just use the formula to get the probability that is between 3.5 equals, so 6.2 cubed minus 8, 335, take away, it goes up to, that's our x, okay? That's our x, remember? That's our x, because it goes from 8 to x. And 3.5 cubed minus 8, 335. Now put all that in your calculator, you will get 0.583. So therefore, when you write it, make sure you write it in terms of like a probability, okay? Not f of x or other things. Equals 0.583. That's all. Next, we're going to the mode. Mode is not most commonly appeared score, it's the maximum. Well, it makes sense because I think it's mostly appeared, so it's going to be high peak, so it's going to be a maximum. Okay, so first one says find the mode of, so where is this high peak here? Roughly, I think it's right there. So if I use my ruler, it'll get up to there. So my mode is 7.7. That's all. Next one. Now, this is the part that we have to think about. Because mode is the maximum point, we need to find f dash x, which is stationary point. And then we have to do second derivative for a concavity. to find out maximum minimum, wasn't it? Right? So it was concave up. If it was a positive, concave up will gives us minimum point. And concave down, when parabola is negative, will gives maximum point. To find the stationary point, okay, so that's the first step. And then we need to check, wasn't it? Because that stationary point is a possible maximum point, possible. And then we just have to check it by doing a second derivative. There's here that hopefully the mode that we are getting, the x value from the stationary point, is in between 1 and 5. Okay, so let's have a look. The first one, we have to find the stationary point. So differentiate that. I will get, this is 3. Yep, that makes sense. Okay, so that's okay. And I'm going to make it to 0. So it'll be 6 minus 2x equals 0. I'm going to, times by 92 over 3 on both sides. So we've got to be all 0. And basically, that's what it is. So x is 3. Now, that's just a possible maximum point. Okay, so let's confirm that. So I'm going to go second derivative from here. So I will go, basically, if I do that, I'll just get minus 3 over 46, isn't it? Because the whole thing will go, all I have is 1 over 92 times, actually, minus 2x. Okay, that's what it is. And then I just simplify. So that becomes minus 2 over 92. Okay, so that's what I've got. That's less than 0. So it's already concave down. So it's going to be like this. And that's our max. So that's confirmed that. So final answer, we found that we've proved that that's maximum. Also that it is in between 1 and 5. Okay, so that seems okay to us, and it just proved it and confirmed as well. So therefore we can say, so the mode is 3. Okay, if you want to, you can say it's concave down, therefore so it's maximum point. Okay, so therefore mode is 3. All right, well that's it for this lesson. Well done.